There's a lot of diversity in combat robotics, as the game is as much about winning your way as it is outright beating an opponent. The two fundamental species that have unequivocally stood the test of time are control robots and spinners. They're yin and yang of winning via careful technical play against simply having the bigger stick and the thicker skin. Interestingly, spinners are the symbol of destruction, as in 30-ish years of robot fighting we really haven't come up with a better way to do damage than spinning a big piece of metal really fast and running it into the other robot. Robot archetypes seem to fall somewhere on this line with examples of success across the board. I've personally built a variety, such as an extremely control-leaning lifter-grabber named Sketch, that effectively smothered and lifted opponents into a pit. Somewhere in the middle is Derive, a feather lifter spinner that used its actuating forks to destabilize and allow a small spinner to get a hit in. On the entirely destructive end, Revolve is a ring spinner exclusively built for damage, with no capacity to manipulate an opponent other than through contact with the hard-hitting ring. A very successful archetype nowadays conceptually fits somewhere in between Derive and Revolve, known in the community as a four-wheel drive vertical spinner. These are popular for their high damage output while also being able to stand their own when it comes to outmaneuvering or getting under an opponent. There are examples of these machines finding success from all weight classes, from antweights all the way up to heavyweights. Wanting a slice of that high win ratio pie with a side of real damage, I set about building my own for the 150 gram antweight class commonly fought in Australia. So what is it mechanically about a vertical spinner that allows it to do so much damage? When a robot with a horizontal spinner hits an opponent, the force imparted on them is roughly equal to the force back into the aggressor. This means a lot of the energy in the collision goes into throwing the horizontal away. Think of throwing a punch at something in space. It's very clearly seen here with my ring spinner. Every collision sends it flying away. What enables a vertical spinner to hit so hard is its ability to pass its half of the impact through framing into the ground. Since the Earth isn't about to notice such a relatively small impulse, the spinner can send more of its engagement putting energy opponent ways. I'd surmise from this that with all else equal, a vertical spinner will hit about twice as hard as a horizontal spinner. The trade-off is that it's easier to store large amounts of energy in a large diameter horizontal than with a smaller vertical weapon, and one needs to consider how much of the reaction force will affect one's machine. If the weapon is very large diameter and is very far outward, the vertical weapon can cause one's machine to topple over as it sort of pulls itself forward on the torque. So with that in mind, how do we exercise this advantage as much as possible? There are many ways to design a weapon to maximize the energy storage and deliverance, which I went about into more depth in my last video about my omnidirectional Eggbeater, but we'll quickly recap here. The more one can concentrate mass far out or make a spinning object more hoop-like versus disc-like, the higher the moment of inertia, which is a measure of how much an object wants to not change its angular velocity. Having a large diameter is the easiest way to increase moment of inertia, but as far as geometry goes, builders eventually arrived in what we call an Eggbeater design, that which the shape is having typically the largest a moment of inertia for a given mass and diameter. The second consideration is speed. The faster the object spins, the more energy it stores. Spin too fast though, and it's hard to get good engagement on an opponent. This is alleviated a little by minimizing the number of impact teeth to one. I had experimented previously with a robot called Revolve V, which was a go-to a ring spinner turned vertical. It had some good fights and occasionally did some good damage, but it had a very hard time getting the ring speed up the size I wanted to. Being so high up, it caused some strong gyroscopic forces when trying to turn. Even though a weapon like this had more potential for damage, I decided on a smaller diameter Eggbeater for my four-wheel drive vertical spinner. It was important that this robot drive well, so consideration was made to how the drive base was structured. A good four-wheel drive tank steer typically has a square wheelbase, where the distance between the centres on the front and rear wheels is the same as the left and right. Fast steering was more important to me than high-speed cross-box control, so I skewed the wheelbase to be wider than it is long. If the objective was for long-running impacts, like seen from beetleweight links, one would go for a longer wheelbase, as this is more stable at speed. Protecting these wheels is paramount, so I need some sort of armour package that covered from all sides without taking up too much of the weight budget. Especially in airweights, absorbing impact energy from deformation has been proving a very good strategy recently. A form of this can be seen in larger robots too, where armour panels are mounted on shock-absorbing mounts that reduce the peak impact force by spreading its deliverance over a long period of time. A robot had recently competed at Wollongong, which was made almost entirely out of TPU plastic, a rubbery material that is incredibly tough but can also be printed easily. I decided to blend the two ideas into a wraparound armour that is mounted rigidly in the middle but relies on the TPU's flexibility to absorb energy across the entire side. It was advantageous to have a thicker panel that is printed mostly hollow to increase bending stiffness so it doesn't flop around too much, as well as being an internal air gap if the outer printed TPU layer is punctured. The frame will be printed from carbon fibre nylon, as this had a high strength to weight and rigidity. Initially I wanted solid carbon fibre panels to support the weapon, so I wouldn't be relying on layer adhesion, but decided to send it as a single piece chassis and see what happened. Finally was an ultralight ABS top plate to just keep the electronics inside, and O-ring tyres on ABS wheels for low cost and weight. The important detail is now the weapon. I had about 55 grams to play with and came up with this single tooth beta bar made out of 4140 steel. Powering it was a 1407 drone motor cut up to be a direct drive hub motor. Rated at 4000 kV, the 8.4 volt power system will lead to a theoretical top weapon speed of 33,000 RPM, or about 250 kilometers an hour at the tip. To lead opponents up to the weapon, there are a pair of fork mounts integrated into the chassis. This helps the weapon catch the underside of low wedges. With that, the robot was christened Split, and it came time to actually build the thing. Compared to my other machines, there isn't a lot to say about the manufacturing process. The chassis were printed uneventfully by a builder with a bamboo X1 carbon. I printed the TPU and ABS parts on my own printers, and the beta bar was lumped into another builder's Senkatsen order to save me the effort. I had at this time not attempted to build Scales beta, so I wasn't confident that I could pull it off myself. With all the parts together, the robot was assembled and tested. The weapon seemed pretty potent and could kick a test chassis around pretty well, but there's no test-led competition. Again competing at Wollongong at the WRC event, Split's first opponent was Steel Storm, built by Richard. This is another four-wheel drive vertical spinner that was even running the same weapon motor and carbon fibre chassis as myself. There isn't much to talk over, so I'll let it play out.
Alright, you guys on the mic might want to watch this one. This one could be eventful. Oh, yeah. Some's eventful. Okay. Alright.
Drivers ready?
Yeah.
Alright. 3, 2, 1, go!
I think he's dead. Oh, he's dead. That's it. That.
Oh no!
Oh.
Yeah, it worked.
Wow. Flip side from the ring spinner, right?
Well, that's cool.
Holy crap.
Get the super glue. Yeah, that'll buff out. That'll buff right out. Oh my god.
Definitely a promising start, with Split living up to its name. By the end of it, it had broken the weapon mount of Steel Storm, which led to the tap out. My strategy, which can be seen pretty easily in this fight, was to ensure that each hit had a good run up to get bite with its fast spinning weapon. Next fight would be quite the testing one, up against Pancake, built by Angus. Pancake was the inspiration for the TPU side armours, and had recently been upgraded with a Hardox weapon bar, which was harder than my beta. There was no reason to run the forks during this fight, so I took them off. The strategy was very much the same against Steel Storm, to drive the weapon as hard as I could into the opponent while avoiding bears. One can see Split's self-riding technique in this fight too, which is to bounce around on this weapon until it lands upright. Around midway through the fight, the Eggbeater's weapon axle bends, causing it to drag on the ground and prevent me from driving forward. Eventually, it fixes itself after a good hit, and I'm back to hitting Pancake.
Oh, I'm fixed.
Between its rubbery chassis and foam wheels, I'm not doing much lasting damage even though these are pretty good hits, but in the closing seconds of the fight, their weapon does eventually break. After this fight, I had to both bend the weapon axle back and transplant all the parts into a spare chassis, as Pancake had broken both the fork mounts off the front of the robot. Pretty brutal for both of us. His weapon motor had cracked a magnet and bent the shaft, if I recall correctly. The next fight was against another vertical spinner named Uppercut and built by Matt. It had a very powerful vertical spinner but struggled to drive with the rear-mounted wheels and heavy gyro effects. I decided to play this fight safe, picking my shots carefully. My biggest concern was hit damaging the beater, or more crucially an engagement, leading them to land on top of me, and the 1.5mm ABS plate being punctured and struck in the battery beneath. The forks definitely helped to get a bite when hitting their front wedges. They eventually had a wheel break off, inhibiting their drive even further. It was too tasty of a target to not try and finish the job. They bounced all over and over into the corner, and potentially I made a costly mistake. I drove into their downward spinning weapon, causing my own robot to tip over. Split can self-right from a stalled beater, but with the heat build up from a long fight and a low battery voltage, I was unable to spin up. I stopped trying once a little smoke came out of the weapon motor, and crab walked my way over to try and engage. Very luckily at this point, Uppercut had knocked themselves out from all that bouncing they did before, so Split scraped by with a lucky win. Final round robin fight was against Dark Blade, a miniature chainsaw wielding robot. A genuine concern as the top plate was very thin. I initially went in cautious, but after a few good engagements I decided to just punish.
Really durable. He's not lying.
Oh,
With 4 wins, Split was seeded second and drawn against Uppercut for a rematch.
Go!
This fight was much simpler this time around, with a weapon-on-weapon engagement that didn't end in disaster. Their weapons seemed to have become more unbalanced, and after a few hits they stopped moving. Semi-finals was against a drum spinner named BFD. It was having weapon spin-up issues at the time, so pretty much just sent the weapon into them until they stopped moving. It was time for the finals against a local builder named Jordan, with his robot, Midnight Sun. We both had undefeated machines up until this point, both forked 4-wheel drive vertical spinners with high revving weapons and carbon fibre chassis. I chose an aggressive start, choosing to get the jump on my opponent. After a few good engagements, Midnight Sun is sent roofward and is seeming to have whipping issues. It took a while for my opponent to actually stop moving, but after a lot of pushing and a few other good hits, Midnight Sun is counted out to give the win to Split. A pretty good result for a new robot, but it's not without its issues. Due to the limited battery life, I couldn't run the weapon motor at full speed for the whole match, so I was limited in destructive potential. But more critically, the weapon axle kept bending. After every match it needed a little tweaking or more. The 3mm stainless shaft I was using was just not up to the task. This easiest option was to swap it out for a grade 12.9 alloy steel bolt, as this was have a much higher stiffness. Aside from that, there wasn't a lot to do to the robot after its victory, other than to get some more practice in, make some spare parts, and bring it to the next event. Split had 2 more competitions, and the results are pretty interesting.
Good. Good.
No, not again! Well. Whoa. You're not even giving him a chance to hit your weapon. Jesus. Oh my god.
Oh no.
Some of the pins are loose. Smack it into the wall. Put it back in. So good. Yeah. Oh, yeah!
Hey.
Try and get some bits on the robot.
Oi. What was that?
Oh no!
Drives out.
He's dead.
That's
Keep fighting, come on.
That's it.
No.
That's a tap. That's a tap. So close. Oh yeah, those forks are oh my god. Oh! Yeah!
10 seconds till the pit. Hurry up.
One of the bunny ears is gone.
Oh no!
Split is a lot of fun to drive and definitely satisfies the hunger for damage. It fought in Adelaide, but unfortunately lost 2 fights and won 2 fights due to an old stretch drive belt and a drive error resulting in a pinning. The second Wollongong event was another clean victory, meaning it is 14 wins undefeated in Wollongong. Just don't worry about that Adelaide stint. That didn't really happen. Adelaide doesn't exist. The next step is to follow my current antweight trend of machining a billet HDPE chassis for Split, which is pretty much indestructible. A new beater that allows for a thickened weapon axle is a good idea, as a 3mm bolt still bent a little. Apart from that, I'm pretty much out of ideas as to how to improve Split. I'll be keen for some suggestions. Probably not going to fight it anytime soon, as I've been working on some new machines that I'd rather give event time to. Next video will most likely cover one of those more unique robots in the form of the Derive project. A spinner lifter that does a lot of damage despite having such a small weapon. Until next time.
3, 2, 1, fight.
Yeah,
That is it.
oh, he chopped it in half.
That'll be it.